Greetings everyone, and welcome to SpaceWeek Live for Sunday, February 21st, 2021. I'm sorry for the late start. I was having to finish up some of my notes, and I've been rushing around trying to get things done here. So yes, questions. If you have them, please ask in the chat. Make sure to tag my name, Rawspace, or at Rawspace. Questions, and that way we are sure to see them, and I'll address the questions at the end of the show, where we can gather them all together. So looking back at last week, a Russian Soyuz rocket designated Progress 77P, a Russian Soyuz 2.1A rocket with the Progress 77P cargo craft, launched last Sunday from Baikonur Cosmodrome in Kazakhstan, bound for the ISS, and it arrived about 50 hours and 34 orbits later. Now the Roscosmos mission designator was MS-16, but NASA calls it Progress 77P. Let's check out that launch real quick. There's not much to see. The conditions were very, I guess, foggy or cloudy. So, but here, let's check it out.
The launch command has been issued. We have engine start and the second umbilical tower separation. Turbo pumps at flight speed and liftoff of the 77th Progress resupply vehicle for its 2-day, 33-orbit journey to the International Space Station.
So, this mission carried, let's see, yeah, here we have the part of the docking coverage. This mission carried propellant, drinking water, pressurized gases such as extra nitrogen, 1,400 kilograms of various equipment and supplies, and a repair kit with reinforced glue patches for the temporary sealing of a leak in the Zvezda service module. As we know, the ISS sometimes leaks, and they are providing the materials to patch that. Progress 77 will stay on station until this July, when it will be loaded up with waste material, as with all departing cargo craft, and it will leave the station together with the Piers module, both of which will deorbit over the South Pacific. Now this is noteworthy because the Piers module was launched way back on September 14th, 2001, just 3 days after the 9/11 attacks. It is one of the oldest components of the space station. And there we go. And yeah, so the space station construction began in 1998. It's been occupied since 2000, and then Piers was launched in 2001. But anyway, it provides one docking port for a Soyuz or Progress spacecraft, and it has an airlock for cosmonauts in their Orlan spacesuits. Now, Piers was scheduled to be deorbited back in 2017 and replaced with the Nauka module, but there were delays with Nauka's construction. Nauka will be launched in late July after Piers is gone. And I am not sure what the process is for sealing up the port, the hole basically where the module docks to or connects to. But I'd be interested to get some behind-the-scenes footage of that, because I've never seen such a thing. Because it's a big hole. It's not just like you know, like where the Soyuz docks to the Piers module. I mean, the connection between the Piers module and the rest of the ISS, I think, is a fair bit larger. I'm not sure exactly, but I could look into it. But that's not the sort of common information that's easily accessible without digging through, you know, documents online and things like that, because it's all out there. But it's just, you know, for like finding a needle in a haystack. Then on Monday, whoops, SpaceX launched Starlink 19 with 60 more satellites for the mega constellation. Let's check out that launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Stage 1 chamber pressures are nominal.
Now, most of that mission looked beautiful and nominal, but there was an issue which prevented the first stage booster from landing on the drone ship. So this is all the footage we got from the drone ship. Let's check that out. So the three little white dots there are seagulls that were hanging around on the drone ship, as seagulls will hang around ships in general. You know, there's a place to land, they will land on it. The seagulls were not the cause for the loss of the booster. That's most likely some sort of engine failure. And but anyway, you can't actually see the booster, but what you'll see is a glow on the right side of the let me go back a few seconds. A glow on the right side of the screen, which is the booster coming down, and then the glow is extinguished as the booster hits the water. Now it is, I don't know if it is publicly known how fast, like the velocity with which the booster hit the water, but anyway, let's check out that footage.
For the sixth time for this booster. Got a live view from the drone ship on your left-hand side. We did get a little bright glow, but no longer see a flame there. Right-hand screen, stage 2 is still looking nominal.
So, yes, all 3 seagulls returned to the circle and were otherwise unperturbed by the explosion of the rocket a short distance away. So that's unfortunate. I think this was the 5th.
We did not recover this booster, but our second stage...
The 5th launch of this booster, somewhere around there. But, yeah, so bummer on that one. But the Starlink satellites did reach their target orbit, which is, after all, the mission. But any loss of a first stage booster also sort of casts a shadow upon the development process of Starship, which will be carrying humans in a self-landing rocket. So, you know, it's a different system with different engineering, but yeah, it still affects the public perception. So hopefully they can figure out what went wrong and prevent that. Oh, I did want to show you one more clip. And this is during the entry burn of the first stage booster. So the burn looks like the burn looks good, but then at the end of the burn, when they say main engine cutoff, or whatever they say, it looks like it continues burning, like in a weird, so it looks unusual. It looks like something down there is still burning and throwing off flames and sparks, which maybe it didn't shut down properly, maybe something ruptured and there was a fire, but let's check that out.
Stage 1 entry burn started.
And there you can see on your left-hand screen as that view lights up, those 3 engines are burning bright, helping to slow the vehicle down as it enters back into the Earth's atmosphere.
Stage 1 entry burn shut down.
We did have a call out for entry burn conclusion. The Earth's atmosphere.
Let's go back a moment here. Entry burn conclusion. Thanks for that, Jessica. So, yeah, so here we have the burn looking pretty normal. And then they call out engine shutdown. And then we see these sort of sparks and flames flying off to the right side there, which is unusual. Once the engine burn is terminated, there should be nothing but like some smoke coming from the nozzle. So likely engine issue there, but hopefully SpaceX gets to the bottom of it and fixes things you know, going forward. I mean, we're not talking about a new launch system. I mean, Falcon 9 has flown many times, so if there's a, you know, it could have been maybe a maintenance issue as opposed to like a flaw in the design. I guess SpaceX's internal investigation will determine that, and it will. I think that only an internal investigation is probably warranted in this case, because the recovery of the first stage booster is essentially gravy for SpaceX. It's a cost-saving measure versus with Starship, where it will be a critical life support function to propulsively land the booster. But let's see. Oh yes, then on Thursday, what a day. The Mars 2020 rover Perseverance, with Ingenuity drones stowed underneath, successfully touched down on the surface of Mars after a journey of 6.5 months and many millions of miles. Let's relive that moment of touchdown here.
We've lost direct-to-Earth tones. As expected. As expected.
Skycrane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has...
Fist bumps and forearm bumps all around. Amazing moment. So, in the exploration of space and in space missions, there is always a great deal of waiting, and I mean missions take years to develop, and sometimes take years to arrive at their destination, even after they're launched. For the outer solar system in particular. But Mars 20, and with billions of dollars, hundreds of millions or billions in this case of dollars invested, thousands and thousands of man hours of labor, and cooperation between agencies and organizations. There's a huge amount on the line in these sorts of missions, and it all comes down to having a successful landing, or getting to the destination, whether it's orbit or a landing. And so that's why they call it the 7 minutes of terror, because let me pause this. Because it takes about 7 minutes from the point of entry interface where the Mars lander encounters the Martian atmosphere, to the point where it touches down, and it's that's just the descent profile of Mars landings, and it all has to go off without a hitch. If any link in that chain were to fail, then the rover will crash, or the lander will crash, and the mission will be a scrub. Will be ruined. And that's the difference. That 7 minutes of terror is the difference between having, years of rich scientific exploration, and having, a painful investigation as to what went wrong, and a whole bunch of people without work. It really comes down to everything has to go right. And so once it touches down, we're good. From that point, we can do, even if there are issues with the rover, if a wheel gets stuck, whatever, they can work out a solution. But if it crashes, there's really nothing we can do. And so that moment of touchdown is a very emotional moment for not only everyone involved, but everyone who's sort of emotionally and intellectually invested in the mission. I choked up myself. It's just an amazing thing when we're able to touch down on another world. And Mars, of all the planets in our solar system, Mars is the most like Earth, as different as they may be. Even though I represent them as a yin and yang, which are sort of polar opposites. They're not really. Mars is closer to Earth than any other planet. It's a little bit colder. It doesn't have much of an atmosphere, but we have a lot of kinship. And anyway, so the descent sequence itself is really fascinating. They pulled some tricks this time that have never been done before, and so the sequence consisted of, and I'll try to just verbally relay this. There are videos out there that JPL has produced that describe the process of descent, EDL, entry, descent, and landing. But basically, what is it, like 13 minutes before landing, something like that, or 18 minutes, the EDL module detaches from the cruise stage, which has solar panels and other stuff that are needed for the journey from Earth to Mars. So it detaches from this donut-shaped cruise stage, and then the cruise stage just burns up. But the EDL contains a heat shield on the bottom, just like a re-entry capsule that we'd use on Earth, except optimized for the Martian atmosphere. And bearing in mind that the Martian atmosphere is only a few % of the density of Earth's atmosphere, so it's not nearly as thick. But and that's actually a problem, because that means that so not only does it not generate as much heat, but it also doesn't slow the craft down as much, which means they have to slow the craft down with a supersonic or hypersonic parachute that pops out. That they had to test that in special, like, high altitude flights or whatever on the Earth, because we can't replicate the Martian atmosphere at scale very easily. So the parachute slows it down, and then when it gets low enough and slow enough, the heat shield detaches and it just craters. The parachute detaches and the descent engine takes over, which is sort of a framework or a scaffold on top of the rover that the rover was mounted underneath, and contains thrusters on a bunch of thrusters around on each of the sides that control the rover's descent and orientation. And actually, this descent engine is a new thing that we've never used before, and it has the capability of actually sort of hovering over the Martian surface and using cameras and sensors to assess the terrain below to find the ideal landing spot, because previous Mars missions all landed in sort of safe zones where there were assessed to be minimal hazards in the way, be it big rocks or whatever, or hazardous terrain features like cliffs. But this descent engine and the EDL system has the capability of actually looking at the ground underneath it and determining where it wants to land autonomously, because remember, there were 11 minutes of light travel time between Mars and Earth at the time of the landing. So we're not controlling these systems live. All we're doing is receiving the signals from them. They're telling us how they did. So a huge amount of effort goes into developing these autonomous landing systems so that they can make intelligent decisions based on on where to land based on their observations of the terrain underneath them. And so shortly before landing, the rover is actually lowered on cables underneath the descent engine to a distance of about 20 feet. And then the descent engine lowers the rover to its designated, or to the point where it's determined that it wants to land, detaches from the rover once the rover has touched down, and then the descent engine thrusts to move off some distance away where it crashes. So that lowering the rover on a crane, on cables, is actually called a sky crane maneuver, which is certainly something that's never been done before. And it went off flawlessly, just amazingly flawlessly. So let's go back to the view here. This is a picture taken by the high-rise camera on the Mars Reconnaissance Orbiter from a distance of, I think it was 400 and something kilometers away from Perseverance. But what we're seeing is in the inset image, we can see the parachute and the rover inside its descent engine, underneath the descent engine. So that the top white blob is the parachute, the bottom white blob is the descent engine and the rover with the back shell, and I don't know if the heat shield had yet detached at that point, probably. above the ground some distance. And then the little circle that you might see if you're not looking on a really small screen, the little circle represents where it actually landed. Now, if you're not used to looking at satellite imagery and you're not sure what you're seeing here, here is a view from above with the different terrain types sort of colorized. So this is the edge of, well, the purple here represents the rim of Jezero crater. The green on the left is outside the crater. The blue is what they call marginal deposits, and then the sort of aqua color is the ancient river delta, and then the red on the right is the crater floor. Now they landed, I think, about 1.5 kilometers from the edge of the river delta, which they estimate to be about a 200-foot high cliff. So, but so that's within driving distance. So I believe that at some point in the lifetime of this rover, they're gonna explore the mouth of that river delta. But yeah, so I mean, I don't have the graphic like handy here, but there was a graphic they presented during their initial whatever briefing on the 19th that showed the sort of red splotches on the ground that represented the hazards, the rocks and the rough terrain, and the EDL system performed beautifully. Like, it landed it right in the middle of a little flat spot amidst a whole bunch of rough areas. So just amazing engineering there. And so this is the view from the Mars Reconnaissance Orbiter, but we actually have a much closer view of the descent from the descent engine itself. Now this is one of the most amazing space photos that we've ever seen. This is actually looking down at the rover, dangling beneath the descent engine on its sky crane cables above the surface of Mars. So this is taken from the descent engine looking straight down at the rover that it is lowering onto the surface, which is just unbelievable. And then you see there on the right the sort of curly cable that twists its way down to the rover, which is the interface, the data interface between the rover and the descent engine. Just amazing. And so once it was on the surface, first in the very beginning we got a black and white image, which was sort of hazy because it was looking through the cover over the landing camera. But once that cover was jettisoned or popped off, we get this nice uncorrected color view of the Martian landscape. And so in the distance we can kind of see some hills. Maybe we might be looking at the cliffs of the river delta, not entirely sure. We see the epic shadow of the rover wheel and the rover, to the left of it. We also see that it's mostly flat. There's some small rocks, not a huge amount of dust, but it looks very Martian. That's what we're looking for. Here's a close-up of one of the wheels and some of the rocks right where it landed. Now, bear in mind, this is the Perseverance is no sojourner. Perseverance is a big rover, about the size of a car or a small SUV, and these wheels are quite large. These aluminum wheels. These rocks that you see are interesting because they look pitted. I mean, they are pitted. And the question is, why are they pitted? Are they pitted from some sort of, erosive process or outgassing or water process? I mean, this is these are some of the questions that NASA is going to be answering, is why do the rocks look the way they do? So they have another briefing tomorrow, which I will be recording. I mean, you can either watch it live on NASA TV. It airs at 2 p.m. Eastern Time, if you want to watch the Mars 2020 Perseverance update briefing. But I will also be recording it and providing a copy on this channel for your viewing pleasure. Just like the other briefings. I actually had a problem uploading those because for about 2 days, for some reason, I was unable to upload videos to YouTube. Every time I would try, it would just sit at like 1% forever and never finish. But I screwed around with my configuration, my computer, and eventually it started working, so I'm able to upload videos again. I didn't have a problem streaming, I just couldn't upload, which was weird. But anyway, so I'll get that uploaded for you after the fact. Or you can watch it live tomorrow at 2 p.m. Eastern on NASA TV. Now, the week was not done yet, though. Finally, and not to be forgotten, on yesterday, a Northrop Grumman Antares rocket launched Cygnus NG-15 bound for the ISS. The cargo craft was named the SS Katherine Johnson in honor of the NASA research mathematician that broke gender and race barriers back in the 60s. Let's check out that launch.
T-minus 10. 5, 4, 3, 2, 1. We have engine ignition.
Main engine start. And we have liftoff of Antares for NG-15 mission. The Wallace flight facility. Engines are at 100%. Attitude, core pressures, and vehicle subsystems are nominal.
The SS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
Commas are important. I'm not sure that John Glenn took cargo to the space station, but anyway. Yeah, so no issues, successful launch, and the cargo is still en route, which brings us to this week. Tomorrow, Monday, February 22nd, starting at 3 a.m. Eastern, 0800 GMT, Cygnus NG-15 arrives at the space station about a day and a half after it launched. Now, a note about the Cygnus mission designators. So technically, I think it's the launch that's called NG-15, while the cargo mission is called CRS-15. But I find that confusing because the SpaceX Dragon cargo missions also use the CRS designator, so I just call it NG-15 to distinguish between the two. Yeah. If it's not quite correct, then you can sue me. It's kind of like Russia using the MS designator for both Soyuz crew launches and Progress cargo launches, even reusing the same mission number, like Soyuz MS-10 and Progress MS-10. Very confusing. Terrible idea. But it is what it is. Then on Wednesday, February 24th, we celebrate the completion of Starman's second orbit around the Sun in Elon Musk's Tesla Roadster. Any of you who've been around this channel very long are very familiar with Starman, as I've been streaming a cleaned up replay of Starman floating through space for almost 3 years now. But yeah, so he's still up there and always will be. Each orbit takes approximately 557 days, as Starman's distance from the Sun ranges from just inside Earth's orbit to a few million miles past Mars's orbit. Starman and the Roadster launched on February 6th, 2018, just over 3 years ago. We actually just celebrated the 3rd anniversary earlier this month. Then on Thursday, February 25th, SpaceX might be launching Starlink 17. If you recall, the Starlink that launched last week was Starlink 19, so we've already had an 18 and a 19. but 17 has been experiencing a sequence of delays for the past three weeks or so for unspecified reasons. Something SpaceX hasn't mentioned what has delayed that launch, but it's been delayed a few times. We don't have an exact time nor official confirmation that it will even be launching on the 25th, but as soon as we get the official word from SpaceX, I'll set up the stream and have it ready for you. So stay tuned for that one. Then on Saturday, February 27th at 11:53 p.m. Eastern, 04:53 GMT, on the 28th, India launches a PSLV rocket with the Amazonia 1 mission for Brazil, as well as Bangalore-based Pixel's Anand satellite and the SatellitSat Cube satellite from the Space Kids India nonprofit. Amazonia 1 will be the first Earth observation satellite entirely developed by Brazil, so kudos for that. Like so many other Earth observation satellites, it's headed for a sun-synchronous polar orbit. Amazonia 1 has been in development for almost 9 years and was originally supposed to launch on a Brazilian VLS-1 rocket, but that program was canceled. Then on Sunday, February 28th, starting at the wee hour of 4:30 a.m. Eastern, 09:30 GMT, coverage begins of a spacewalk with astronauts Kate Rubins and Victor Glover. The spacewalk starts about 90 minutes later and will last about 6.5 hours. Also on Sunday the 28th, sometime between 9 a.m. and 6 p.m. Eastern, 1400 and 2300 GMT, SpaceX might launch the Starship SN-10 prototype on another 10-kilometer test flight. As we know, these test schedules are very fluid, and bearing in mind that the last 2 Starship high-altitude tests ended with explosions, the date could and very well might shift. So stay tuned again for that. We have to play the Starship launches by ear because the dates slip constantly, and we never know when it's actually going to happen until it happens. So that is it for this coming week. I would like to offer a hearty welcome and thank you to new members, all Rawthlings, Anthony USMC, also one of our moderators, Friday Ray, a visitor emeritus from the Lab Padre Nerdle, Shenandoah Smith, and welcome back to Robert Washburn and Max Crew, also one of our moderators. So I'll now look at your questions. If I can get myself ready for that here. Thank you so much to Chris V for helping me out with the question curation. I appreciate it. Okay, Toon Vanderpass. It continues to amaze me that NASA is able to land so precisely at the targeted spot on Mars. I know about inertial guidance, etc., but still, how on earth do they do that reliably? Well, I think the answer would have to be that they take it in... Well, first of all, the systems are meticulously developed and tested to the extent of our ability within the environment here on Earth. But also, they take it in phases. I mean, the cruise phase is very different than the descent phase, which is, and each system is like the descent sequence. You've got the detachment from the cruise phase, the entry interface with the atmosphere, the deployment of the supersonic parachute, the detachment of the heat shield, the detachment of the back shell, the engagement of the descent engine, the detachment of the parachute again. I mean, well, not again, but the detachment of the parachute, and then the lowering of the rover on the sky crane, and then finally the touchdown of the rover and the detachment of the descent engine and the boosting off to crash elsewhere. Many steps in the process, but basically, if you recall, when we've landed on Mars in the past, we've used balloons to sort of bounce along the surface. We've used retro thrusters to slow down our descent at the last minute. They've used a few different systems to land on Mars, and but this one has allowed the most precise control of the landing, because for the first time, they're not just aiming for an ellipse. Now remember, on their approach to Mars, they do periodic corrections to the trajectory in flight, as they approach Mars, to make sure that they hit their target, angle and location in the atmosphere. And but in this case, they did a bang-up job with aiming, really, because they hadn't performed, I don't remember the exact numbers, but they hadn't performed a trajectory correction maneuver in like weeks, because they were so spot on. I mean, they've really gotten good at hitting their target. But this time they weren't just aiming for an ellipse. They actually had an intelligent EDL system that was able to make decisions regarding where it wanted to touch down and relocate itself if needed. So it's not like they just threw the craft at Mars and then prepared the craft to land in whatever environment it encountered. The system actually made an intelligent decision as to, okay, I'm not going to land on this terrain, I'm going to keep going and land on this terrain. And that's, that kind of artificial intelligence, if you want to use the term, that's an overused term, but anyway, let's just call it an intelligent landing system, allows for a great deal of precision in landing, safely, because you're not going to be landing on a big rock because it has looked at it and said there is no big rock there. But Mark Desert, I'm reading the Ingenuity drone will not fly higher than about 5 meters. That isn't terribly surprising. So the Ingenuity drone, or helicopter, or Marscopter, is, first of all, it's very, very light. Now remember that the Martian atmosphere is quite thin, so that there's not much air or not much atmosphere for those rotor blades to grab onto to provide lift. And so it's a very, very light craft. And it is really just a tech demo. It's not intended to perform any sort of heavy science functions. There may be a camera on the drone, but it's minimal. And so they're going to, demonstrate their proof of concept, fly around a little bit, and that will be basically it. It'll be amazing to see, and it'll certainly be the first time that any free-flying craft has operated on another world. But it's not like bristling with sensors and scientific instruments like the rover itself is. So it would not at all surprise me if it was a very modest flight, but it'll still be historic nonetheless. Also Mark Desert, and that it will only do several short hops. More of a demonstration. Okay, yeah, right. I should have read ahead. More of a demonstration of the technology than doing any potential discoveries on the Martian surface. That's exactly correct. It's a tech demo that it isn't going to be doing any heavy lifting, literal or figurative. Figural. There you go. There's a new word. Bill Brindle. Do they have video of the Mars landing? So the thing is, the data, the processing capabilities of the computers on computers on the Mars rover, the 2020 Mars rover, are far and away more advanced than previous ones that have gone up there. However, we're still limited by bandwidth. So bandwidth, transferring data at interplanetary distances is tricky and difficult. So they still have to receive the data on the the deep space network of radio dishes that are positioned at 66 degrees. There's 3 installations positioned at 66 degrees apart from each other around the globe. And so that at any given time, at least 2 of them will be able to have, radar dish eyes on a given target. And, and those are old facilities. But in any case, so bandwidth is very limited at interplanetary distances. And so the data will come, and they will have maybe not a video. I guess they took video. Supposedly they have cameras like on the descent engine and on the rover and whatever. Supposedly they have multiple cameras, video cameras, on both of those systems. But that data will take time to be gathered. So some of the data can be sent directly from the rover with its high-gain antenna. Other data will be relayed up to the Mars Reconnaissance Orbiter, and I don't actually, off the top of my head, know if there are any other orbiters that we have up there. I mean, there's the UAE and the Chinese orbiters, but other than MRO, I don't recall if there are any other, like, American rovers. American orbiters, I should say. But in any case, some of the data is sent directly, some of it's relayed through an orbiter. But whatever media they produce, the video, the audio, because they supposedly had microphones on this thing, it will come out, and they'll probably have something cool to show us tomorrow. But it's just like the New Horizons mission to Pluto. It took time for the really sweet high resolution photos to be transferred. Although that's sort of a couple steps beyond Mars, but still the same principle applies. Rockin' Robbins 13. Oh, wait a minute. All right. Smee Self. Why are SpaceX fanboys so negative about everything else? I don't think that's a characteristic necessarily of being a SpaceX fanboy. I think it's more so a characteristic of people being online. Folks online, they tend to be tribal and dramatic and exclusionary. This is my court, and you can't. People online are very contentious. Just go on Facebook, and that's the whole freaking platform thrives on contention. Which is why I hate Facebook. But that's kind of social media in general. But with regards to SpaceX specifically, SpaceX is the only launch provider in the world, and SpaceX is a private company, right? SpaceX is the only launch provider in the world, not NASA, not Roscosmos, not the Chinese Space Agency, not anybody else, can reliably reuse large portions of their launch system. Now, the Falcon 9 upper stage isn't reused, but the first stage is, and Electron is working on that capability, but they're not quite there yet. And that's a small rocket, with a small payload capacity. But the fact that SpaceX has forged ahead with this dramatically more efficient method of launching payloads to space, where the bulk of the rocket can be reused many times, up to 10 times or whatever. I think their max is 8 now, is it? Is significant, that's not to say that people should argue about it or that people should pick on other launch providers. We're all on the same Team Space, right? And we should be rooting for the proliferation of operations in space. We should be rooting for humanity's continued use and expansion into space and exploration thereof. So I'm not a fan myself of the sort of, you can't reuse your rocket sort of attitude that some people have. But again, it's the internet, so people are gonna fuss about stuff. It doesn't mean that, you know, SpaceX is bad because some of the people who are fans of SpaceX have a tribal attitude or a whatever. But it is what it is. What we can do is set an example for them by being a little more level-headed and inclusionary rather than exclusionary. You know, so be a fan of SpaceX, be a fan of ULA, be a fan of Arianespace and JAXA and Roscosmos and ISRO and all the others. Because, you know, ultimately the more we're in space, the better off our species will be. That's the opinion of me anyway. Now, Rockin' Robin's 13. Why isn't the Mars Reconnaissance Orbiter able to get actual video of the Perseverance landing? So I don't think MRO is equipped with a video camera per se. It can take images, but I do not know the frequency with which it can take those images. You know, like if it can only take an image every, you know, 30 seconds or whatever, I don't know. I have no idea what the MRO's capabilities are. And remember, it's orbiting pretty quickly across the you know, the Martian surface, and so it would constantly, like if it were to get a video of the Perseverance landing, it would have to be constantly reorienting itself to reorienting its camera to you know, because remember it was something like 400 and some kilometers away from the Perseverance rover at the time. So I don't know. I mean, we'd have to look up the specs of the MRO and see. I guess the critical factors would be how quickly can it take pictures, and how quickly can it reorient its camera, because it's orbiting and it would need to follow the rover beneath it. Bryab 5K boss. When is Space Dragon cruise heading home? I don't have the dates handy, but the expedition crews typically stay on station for about 6 months. That's a normal length of an expedition stay on station is 6 months. So the last one launched, was it 4 months ago? I don't even, time is meaningless. Just measure about 6 months from the time that they launched is probably roughly when they're expected to return. I could look it up right now, but it's, you know, you're any of you are just as capable of looking it up. Just look up Crew 2 return, or Crew 1 return. There you go. Crew 2 hasn't launched yet. Let's see. Rockin' Robin's 13. Any news on the cause of the booster loss from the Starlink launch the other day? I have not seen anything, but I've been pretty tied up. I'm in the process of trying to tidy up my house, get my things in order so that we can move a short distance. Not relocating to a different region yet, but relocating to a different house. And so I haven't spent a ton of time trawling the interwebs for details about that. But, you know, probably NASA Spaceflight or one of the other big forums where people talk about these things. If there's any sort of insider information that has come out, then it would probably be located there, Reddit, somewhere on Reddit. Tommaso Zuccol. What about the Alpha Centauri project with laser propulsion? Starshot, isn't that what it was called? Project Starshot. Very cool. I don't have any new information on that. Let's see. I'm trying to think. No, it was the Planetary Society and Bill Nye that launched the miniature solar sail, wasn't it? God, they launched something a couple of years ago, but it was an experimental thing. As far as whether any kind of attempt at any kind of real attempt to accomplish that laser-propelled micro starship mission, I haven't heard about any progress on it, if anyone's actually pursuing it seriously. And we'd also have to consider, consider who would be firing the laser. And, the Earth rotates, so would there be multiple laser installations around the world, or would they have to be, maybe satellite-based? Moon-based? I'm not aware of any real progress on that mission, but it's a really cool idea in any case. So let's see. Crystallina bacteria. If they put plants on Mars, will it change the atmosphere? Well, theoretically, putting anything anywhere changes the environment to some degree. But first of all, the Martian environment is not very fertile. It's basically a dead planet. There's essentially no oxygen in the atmosphere. There's carbon dioxide, which contains oxygen atoms, but so I guess by that token, the plants, would have carbon dioxide available, even though the atmosphere is thin. But the soil is perpetually irradiated. There's no magnetosphere, no planetary magnetosphere to protect the planet from bombardment by ionizing radiation. Cosmic rays. The atmosphere is thin, and so that's even more exposure that the surface gets to radiation and cosmic rays. And furthermore, planets are big. The Martian atmosphere might be thin, but it still contains bazillions, literally bazillions, of tons of carbon dioxide. In order to make a dent on that, if we wanted to terraform Mars, it would take centuries at a minimum, if not many millennia, to affect any substantial change. And the atmosphere is constantly getting stripped away by the solar wind because there's no magnetosphere to protect it. So plants on Mars, not really going to have any effect on the Martian atmosphere. Nothing substantial in the foreseeable future, unfortunately. Maria C. Kutujan. May the wind took the booster out of his route, referring to the Falcon 9 booster that splashed down, thus saving the lives of those 3 seagulls. No, I don't think the wind took it. Remember that the Falcon 9 first stage is guided down through the atmosphere by, not only through the thrust vectoring of the engine during the entry and landing burns, but also the titanium grid fins guide its path down through the atmosphere. And I don't think that the wind was the problem. And remember also that the ballistic trajectory, the uncorrected trajectory of the Falcon 9 first stage to the vicinity of the drone ship is actually not, it's not pointed straight at the drone ship. It's actually pointed off to the side, to the water. Because if something goes wrong, they don't want the rocket to blast its way into the drone ship. They would rather it crash in the water. And so they actually perform, during the landing burn, they actually perform a corrective maneuver to reorient the rocket over to the drone ship. Because, if it's just descending and they don't fire the engine or adjust its trajectory with the grid fins, it's just going to splash down. It's going to crash in the water. So it's actually not so much that it was off course. It's a matter of something was wrong and it was unable to do its planned course correction at the end of its descent so that it could land on the drone ship. Maria Kutujan, does SpaceX jump L-17 number for launching Falcon 9 Starlink? So normally when SpaceX broadcasts a Starlink launch, they don't mention a mission number. They just say Starlink launch, and it's minimal, you know. But the mission designators that are used, I'm not sure where those actually come from. Like when you see Starlink 17, 18, 19, that's a number that's used by the launch schedule websites, third parties that keep track of this stuff. And so I don't actually know for sure if that's a SpaceX internal mission designation or if that's being imposed artificially by these third-party scheduling websites. I've wondered about that myself. So, but 17 was scheduled, and that and that launch was delayed, so they proceeded with numbering the next ones 18 and 19, and the 17 one is still waiting to be launched. MVM Motovlog Music. When it comes to landing on Mars, the parachute deployment is always the biggest question mark. Yeah, parachute deployment is complicated because it's pure physics at that point. Is the chute going to hold? Is it going to, well, first of all, is it going to deploy out of the back of the EDL module? Is it going to unfurl correctly? Is it going to tear? Is it going to break off and fly away, as has happened with some missions? So yeah, parachutes are inherently a big question mark indeed. Also, MVM Motovlog Music. Which of the Perseverance systems am I most excited about? Well, the one that I've heard the most about is MOXIE, which is the I don't remember what the acronym stands for, but it's the experiment basically that will convert Martian atmosphere CO2 into oxygen, which can be used, you know, in future systems, could be used for breathing, or perhaps for synthesis into H2O, water, also for rocket fuel. Hey, Bennu. Oh, hey. Nice. Here we go. Check this out. Ba-doop. Hey, buddy. He and I had a tough time today because I had to give him his medicine for his digestive problem that he has, or his Giardia, intestinal parasite that he has, and he does not like that medicine. Anytime he sees me grab the syringe, I have to chase him down. He runs away, and then I have to restrain him while I give him it's an oral syringe, so you squirt it in his mouth. And he was resisting, and he was jerking his head around. I ended up squirting the medicine all over his face and all over my shirt, not this one. And it was very traumatic for both of us. And and it was unfortunate because I lost a whole dose of medicine because it squirted all over the place. So tomorrow I'll have to call the vet about that and ask if I can get some more. But yeah, his issue still isn't solved, but hopefully he feels better soon. In the meantime, he's grooming himself. Chris V. Oh, I'm sorry, Roger C. When Curiosity landed, did the sky crane smash the weather sensor? I'm not sure where. Did the sky crane smash the weather sensor? So if you're referring to a weather sensor on the rover, I wouldn't think so, because the rover was dangling on cables underneath the sky crane, the descent engine, and then upon release, the sky crane or descent engine boosted off to crash a ways away. So I'm not actually sure where the weather sensor is located on the rover. Mobile Armored Strike Command. NASA is currently working on a drone called Dragonfly, so it will fly to the moon Titan, Saturn's largest moon. I have a problem with Dragonfly to Titan. Titan's atmosphere will destroy the drone like Titan did to Huygens. So how can NASA design a drone to literally survive the extreme harsh environment? So Titan is very, very cold. It's a dynamic environment, but it's very, very cold, and it has a very thick atmosphere of stuff, of like methane, I guess, is mostly what's in the atmosphere. I remember, let's see, it's been a while since I saw a video describing how they were designing it, but they're planning for that. It's going to be specifically designed, like Huygens was not designed to last for very long, and also Huygens was designed back in the 90s. I mean, if you recall, Cassini was developed in the 90s and took, like 7 years or something to reach Saturn, and then orbited Saturn for a number of years before it was deorbited a couple years ago. But they're specifically designing it to survive the Titanian environment, I guess you'd call it. And as far as specific features of it that would allow it to survive that environment, I am not sure. I mean, the materials that will be used, I think it has some sort of heat generation capability. I don't know if that's with an RTG, or which is probably where it's deriving its power from, with an RTG battery, radioisotope thermoelectric generator, which is also how the Mars rover generates its power. But the important things are keeping warm and not being eroded by things, I guess. Dark Penguin 197. Is it possible the U.S. sanctioned Russian and Chinese space agencies to use American technologies? I mean, the space agencies do have, they do cooperate, obviously. I mean, we and the Russians are closely tied together in operating and building and maintaining the space station. But mostly, I think, the systems stay separate. Like, you're not going to see Russian systems and Chinese systems and American systems integrated per se. Like on the space station, there's a Russian half that Russian craft dock to, and Russian spacesuits are used, and Russian cosmonauts occupy. And there's an American half, or whatever, and everybody else half, mainly American, where the astronauts, the European Space Agency astronauts, the NASA astronauts, Canadian astronauts, Japanese astronauts, are on the other side. So there's really not so much integration as there is cooperation. But now that's Russia and the United States. Now China is a different matter. They don't really play with others, and that's been, cooperate. I mean, that's been largely a political issue between the United States and China. But even Russia and China don't really collaborate on space matters that I'm aware of. Although most of Chinese designs have their origin in Russian systems, so how that came about, that's above my pay grade. But interesting questions, though. Let's see. Now I have to wrap this up pretty quick because I actually have a house I need to look at pretty soon, and I need to get there. Dark Penguin 197. Oh, yes. Adil Abbasi. Do you think mining Mars for resources like gold and minerals in the future? So, the surface of Mars is mostly iron oxide, rust, basically. That's what gives it its reddish brown color. And it's not known that there are any particularly valuable or useful minerals on Mars, but I mean, it is a planetary body, so if we were to dig deep, we could find all sorts of stuff. but it's not as active a world as and dynamic a world as ours is, and you're not going to find like Earth's resources have been shaped a lot by the life on this planet. You know, oil and all sorts of sedimentary rocks and things like that are deposited and created from life. Well, Mars is not gonna have that. But so I don't think it would, and plus getting off of Mars and back to the Earth is expensive. So I don't think it would probably be beneficial to mine Mars, except for use on Mars. Or perhaps except for use in systems that will be used beyond Mars, for example, in the asteroid belt. But the asteroid belt is a trove of material in itself. So I think that most of any mining on Mars in the future will be done for the benefit of Mars. Dark Penguin 197, do you think we must sanction our adversaries to block their space programs? I don't think that any level of sanctioning will prevent other powers in the world from proceeding with their development of space systems, and we don't currently have a stated national interest in preventing other countries from pursuing space. We have a stated interest in preventing countries from pursuing nukes, but that's a different matter. No, I think that in cooperation lies our future. If we can just start getting along a little better. Magical Ducks, I like the name. What do you think of Project Orion? Are you referring to the proposed nuclear propelled craft where they actually detonate nuclear bombs to propel the vehicle? I think that's wild, and it was demonstrated to very dramatic effect in the Larry Niven and Jerry Pournelle novel Footfall, which is very cool. You should read that sometime. Yeah, detonating nukes. You don't want to do that on Earth. Maybe feasible in space, but if you're getting a bunch of nukes up into space, that's, politically fraught to begin with. So I'm not sure if that idea will go anywhere. But it's an interesting concept in any case. James Tiberius Kirk. Really, I have to believe that in 2021 we use 1950s rocket technology. I mean, chemistry is chemistry. There's no magic wand that we can wave to make atoms and molecules behave differently, which is why the fuel that's used in Falcon 9, which is the world's most advanced production rocket, is essentially the same fuel that was used in the Saturn V more than 50 years ago. So, the problem is we are bound by the laws of physics and we're bound by the rules of chemistry. And so until propulsion, until we come up with some whiz-bang new method of generating a large amount of thrust, a high, a large amount of thrust, I mean, we're stuck with the chemistry that we have. As far as the shape of the rockets, I mean, that's simply aerodynamics. Again, the laws of physics. We're bound by it. If we can find a way to cheat physics or to come up with some new propulsion mechanism which is a quantum leap ahead of the chemical methods we use now, then that'll be great. But until that comes, we're kind of stuck. Mark Desire, have I read Red Mars, Green Mars, and Blue Mars by Kim Stanley Robinson? Amazing book series. Yes, I have. And that's actually, that book series, Red Mars, Green Mars, and Blue Mars, were a big inspiration for me. They really sort of made me fall in love with the planet Mars and see it with different eyes. I recommend everyone read those books. Carl Jones, this will be the last question. Carl Jones, Raw Space, when will SN10 fly? Maybe, kind of, sort of, maybe, this next Sunday, the 28th, but that is very much subject to change. So, it might fly next Sunday, but again, wait and see, and keep an eye on the TFRs, the temporary flight restrictions from the FAA. Just go to go to tfr.faa.gov and filter by space operations, and then you'll see the TFRs for both Boca Chica and the Cape, and anywhere else in the United States that might be launching, which I don't think is anywhere else in the next week. But yeah, stay tuned for that. Now, I'm going to have to wrap it up. I'm actually probably going to be late to my house viewing. I have to apologize to my realtor, but thank you all so much for coming. If there were any unanswered questions, I am very sorry, but we had a good chat today, and again, I greatly appreciate you taking time out of your day to hang out here on Raw Space. And until next time, keep it raw and do take care.